Okay, grade 7, my apologies. It's 7:30 on a Monday night. You're supposed to have this a long time ago, but I forgot about it. So you got it now, and hopefully it'll help you as you do your homework. So first question says, Deepa, determine the area of this parallelogram to be 5 centimeters squared. Explain her error. Well, remember, this is a parallelogram, and this technically is the base. But in order for me to get the area of that particular parallelogram, I have to multiply the base times the height. And the height is the perpendicular distance from the parallel line at the top to the base. So this distance here is not the height. In fact, we don't know the height. So because we don't know the height, we can't actually tell the area. So our error was 2.5 centimeters is not the height. And do the calculation correctly, I can't, because I don't know what this is. I guess if I used Pythagoras, I could figure it out, but I can't figure it out. So the answer is I can't figure out the correct calculation. Question 3, it says determine the area of each parallelogram. Well, I'm going to do B first. This is the base, which is 1, 2, 3 units long. And the height is the perpendicular distance from the parallel side down, which is 1, 2, 3. So our formula is base times height. I'm just going to write BH, just like I would X, 2X. The base is 3, the height is 3, and therefore the area is 9 centimeters squared. That's the area for this one. Now the second one, B, the reason why I did it second is because really in order for me to see the area, I have to kind of turn it around here. So the base for this one is 1 centimeter. And the height is this distance here. So it's 1, 2, 3, 4. The height is 4. So base times height is your formula. Base is 1, height is 4. So therefore your area for that second one is 4 centimeters squared. Question 5 I'm going to skip because I can't draw 5 or 6 on a smartboard. Question 7 says, what is the area of each parallelogram? So the first one's drawn for you. The base here is 11. So B times H is my formula. 11 is my base. H is the perpendicular distance from the parallel side to the bottom. So that height is 5. So we have 11 times 5, which is 55 square centimeters. Now B is a little bit unique because it doesn't give you the parallelogram, but you could draw it if you wanted to. I'll just draw this one here. The base is 7 centimeters. The height is 9 centimeters. So base times height would be 7 multiplied by 9, which is 63 centimeters squared. And the last one, C, the height is 6.2, so I'll just draw another parallelogram. The height is 6.2 meters, and the base is 3 meters. So the area would be base times height, or 3 multiplied by 6.2. Now 3 multiplied by 6 is 18, and 3 multiplied by 0.2 is 0.6. So your answer is 18.6 square meters. Question 8, determine the area of this parallelogram. So here we have the base. So the base is 3. And the height, it's hard for me to go upwards to this. So I have to actually either extend the line this way or extend the line this way. But that perpendicular distance, if I had to take a measuring tape, I would measure it straight up like that. And there it is right there. So the height of that particular parallelogram is 9 meters. So therefore 27 square meters is the area of the parallelogram. B, I'm not going to draw it this time, but our formula is B times H. Our base is 9.2. Our height is 12.3. Can't do that in my head this time, so I'm going to take my calculator and go 9.2 multiplied by 12.3. That is 113. The area is 113.16 millimeters squared. And your last one, the base is 4.5 and the height is twice the base. So this one I'm going to draw just to see it. So the base is 4.5 and the height is twice the base. So if this is the height and it's twice the base, it must be 9. So therefore base times height will be 4.5 multiplied by twice the base, which is 9. 4 times 9 is 36. Half of 9 is 4.5. So 36 and 4.5 is 40.5 centimeters squared. Question 9, we have workers are putting new flooring in the community center. A section of the floor is going to be a parallelogram shaped design. There are enough floor tiles to cover an area of 12 meters squared. The base will be 3 meters. What can the height of the design be? All right, so we know that area, the formula is area equals base times height. So if we substitute what we know that, I'm going to take my highlighter here, we know that the area is that, and we know that the base is that. So if I take my thing in base times height, so I know the area is 12, and I know the base is 3. So really, when I substitute what numbers I know, I really have this 3h equals 12 or 12 equals 3h, and this is just a one-step algebraic equation. If I want to solve for it, I'm going to divide this side by 3 and divide that side by 3, and I get h isolated. 12 divided by 3 is 4. So therefore, the maximum height the design can be is 4 meters. Algebra. Who knew it worked? Question 12. It has a picture of a cute little koala bear, I think. It says a parallelogram-shaped stripe is going to be painted on the wall of a daycare center. There's enough paint to make a stripe with an area of 9 meters square. How high can the stripe be? Exactly the same question. So we have area equals base times height. The area is 9 meters squared. I should put 9, sorry, not 9 meters. The area is 9. The base is 1.5. And the height. So here we have to isolate the variable by dividing this time by a decimal, which is actually a grade 8 outcome. So we're going to divide both sides by 1.5. We get h. 9 divided by 1.5. I know the answer, but I'm going to show you in the calculator. So if I take the calculator here and go 9 divided by 1.5, it is 6. So therefore, the maximum height that wall can be, or that stripe can be, is 6 meters. Question 12, we have a rectangle shape A and a slightly askew rectangle known as a parallelogram in shape B. For this formula, we're going to use the formula length times width, because it says which of the two areas have, or which of the two shapes has a greater area. So length is, it doesn't matter which one, we'll use 6 for that one, and we'll use 2 for this one. So the area of this rectangle is 12 square centimeters. The base times height is your different formula for a parallelogram. Your base is 2, your height is 6. You also have 12 centimeters squared. So the answer is they are the same area. Question 13, you have this wonderful bridge, parallelogram bridge going across a section of the schoolyard. So what we have here is this is flooded, and this is our bridge that goes across this crocodile-infested. That's a good crocodile, actually. Not a bad crocodile at all. Crocodile-infested schoolyard. So we're going to write down our formula, area equals base times height. Now again, we know that the area of the walkway is 22, so I'm going to substitute that in. We know that the base is unknown, and we know that the height, right here, the height of that is 11. So the base we don't know, and the height we do know. So I'm going to substitute that in. And what we have here is we have a variable in front, and our coefficient in the back. And since that's b times 11, or 11 times b is the same thing, we're just going to rewrite that. Instead of a b times 11, we're going to go 11 times b, or 11b. And then to isolate, we're simply going to divide both sides by that coefficient, which is 11. We isolate the variable as b, and we get 2. So therefore, the maximum height, or the maximum length, the base, or the width of that bridge can be is 2 meters. Question 17 says a construction company is building a road through a rectangular section of farmland. The farmer wants to know the area of land being used for the road. Determine the area in square meters. So this is kind of a little bit tricky, because what we have to be careful of is this unit is kilometers, this unit is kilometers, and this unit is meters. So since the area says determine the area in square meters, what we're going to do is we're going to change all of these to meters instead of kilometers. So 5.4 kilometers is 5,400 meters, and 1.8 kilometers is 1,800 meters. So instead of using those two things, we're going to change it to that. And now that we have them written in here, this is a much easier question. So our parallelogram has a base of 15, so area equals base times height. Our base is actually 15 meters. Our height, the perpendicular distance from the, I can do it this way too if you want, any way you want actually. That perpendicular distance from the base to the top is going to be 1,800 meters. So we're going to go 15 times 1,800. So 15 times 1,800 is 27,000 square meters is your answer. So the area of the road will be 27,000 square meters. And I think your last question is this one. It says, what's the area of the paving stone needed for the patio? So here we have really, if you think about this paving stone, we have a parallelogram up here, right? There's our parallelogram, and then we have a rectangle here. So we have a rectangle and a parallelogram. So what we're going to do, I'm going to take my red marker, and I'm going to take this parallelogram, I'm going to draw it over here. And then I'm going to take this rectangle, I'm going to draw it over here. And we know that this paving stone is going to be those two combined. So this one we know it's 9.5 times 6. So we're going to go length times width, 9.5 times 6. That's 45 and 3, which is 48 meters squared. That's the area of this bottom part. Right? And all we have to do now is figure out the parallelogram. So we know that this is 9.5. So we know that this is 9.5. So I'll write that in as my base. But the tricky part is, how high is this here? Okay. Since this whole thing is 10, and this over here is 6, then this must be 4 because 6 plus 4 is 10. So therefore, the height of a parallelogram is 4. Area of a parallelogram is base times height, so it's 9.5 multiplied by 4. 9 times 4 is 36. Half times 4 is 2. 36 and 2 is 38 meters squared. So I'll put that in here. And therefore, our answer for that is 86 meters squared, because I'm going to add those two together. So our answer is the paving stones for that patio will require 86 square meters of paving stones. So if paving stones cost $55 per square meter, how much would it cost to pave the patio? So if I estimate, well, $55 times 100 would be 550. So it's going to be less than 550. I'm going to guess probably around 500. I have no idea. Then says calculate the cost. So 86 square meters of paving stones multiplied by $55 per square meter will equal, if I take my calculator out again, 86 square meters multiplied by the $55 per square meter, that equals, oh, did I make a mistake somewhere there? Yeah, I guess so. 4,000. I guess I did. $4,730. I think my estimation was way off. I can't remember what I did, but I think I did something wrong. But anyway, that's the correct answer. So the correct answer was $55 per square meter, and you require, oh no, I said 5,500, that's right. And you require that much, so you'd probably have about a lot of money you have to save up in order to build a patio stone patio. Okay, thank you, grade 7, for being so patient. We'll see you tomorrow morning.